Hi, I'm Christoph from Berlin, Germany, and I work for KDAB. This is already video number 8 of our series on effective embedded software development. You can find all the videos of this series in the description. But now for this video. As an embedded developer, you know this one situation very well. You're working on a piece of software, but it is hidden behind 5 clicks. You need to log in, then navigate, make some changes, and only then you see the code changes and whether they are correct. In this video, I show you how to deal with this situation and how to automate these annoying 5 clicks you need to do 100 times a day. Okay, so here we see our little application that we will work on today, which is again this LED application that you know from before. Here's a new screen that was added, which is a login screen. So every time I want to see my changes, I have to log in first. So I write Christoph, and then I write the secret password, which is secret. And then I have to click login, and only then I see my code. In this case, you see that these little bubbles should be on the ring and not off the ring. And I know what is the mistake here already. So I'm going to go ahead and fix the code. So I'm going here into my editor, and I see that formerly I had the ring width divided by 3, but now I only use like half of the width, which is the problem here. So I fix this, press the start button, and then again I see my login screen. So I need to go here, write Christoph, write secret, and after clicking login, only then I see that my code actually changed the behavior of the application, and it's now fixed. So imagine doing this 100 or 200 times a day. This is very annoying. One solution to this is hot reload. With hot reload, you can verify changes in the app without a restart and without needing to navigate from start. If it works, I can see my changes right after I edited and saved my code. See the video Hot Reload for QML, where I explain exactly this, even with an example implementation. But hot reload is not always possible. What if the code structure changed such that the changes are not in the same file anymore? Then you cannot use this solution. But there's other solutions. The second solution to this problem would be to hard code your start screen. So here I would go to my main QML file, and I would see that the loader loads the login page on start. Instead, I can just load the app content on start. And when I start now, I would already be greeted with the page that I'm currently working on. So here you would see the mistakes that I did and which I need to work on. Remember, this trick is kind of cheating, does not work all the time. Just imagine that you're logging in to your customer's server and you're greeted with real data. So you're needing to work on that real data for your job. Here it's not easily possible to just skip the login. The login will be necessary. The solution I actually want to talk about in this video is auto input using the open source library Spix. With automated input, we can achieve input from the outside without altering the software code. We have seen that Qt applications can be instrumented and injected by Gammaray in my Gammaray in Action video. Here, input forwarding becomes possible between remote devices, for example, sending clicks to the touch screen from the laptop. So what we can do is to inject clicks to Qt applications with Gammaray. However, Gammaray cannot execute previously recorded input replays. To actually achieve this goal, I use Spix, a little library that makes your UI elements searchable and clickable with scripts, in my case written in Python. In the end, these little scripts can even be checked in, so other developers can profit from the automation you created. One way to install Spix into your project would be to use a Git submodule. So here I'm using a third-party Spix folder where I want to include Spix as a submodule into my existing project. So this is now cloning and adding it to my project so it can be used. After adding Spix to your project repository, we also need to register it with CMake so it can find the library in the project. So I will go to the CMake file, cmakes list.txt, and you will find a find package call that says Spix is required. Please note that Spix is a little bit broken when it comes to CMake, so you need to specify the installation path of Spix where it has its CMake modules here as well. In the end, we only link to Spix via the target link libraries call. So at the end of this very long call, you will find Spix here as a dynamic library added to the project. So Spix can be used to have automated input in your application. This is the library part. After having registered Spix within CMake, we also need to add it to the main application. So I go into my main CPP, and here you will find Spix included as header files, as well as 3 lines that we always need to include to actually run the Spix server. So here, the first line will add the AnyRPC server, which is the interface we can communicate with over network. You will see that later. Then we need to create a new Spix QtQML bot. And lastly, just run the test server on the test server, which is now reachable under a certain port. With this, we should be ready to go, and I can show you Spix in action. First, let's check whether Spix is actually running in the application that we just started here from Qt Creator. So what I will do, I will look for open ports, and I will see that the LED app actually shows up with port 9000. This is a clear sign that Spix is running within the application and it's waiting to get commands from the outside so we can remote control our application. I will now write a little Python script or go into interactive Python mode to show you some simple functionality of Spix. So Python, and within Python I need to open an AnyRPC session. So this is XML, and I will be using the XML RPC library for this. After importing this, I need to open a new session. As you can see, I will be using localhost here, so I'm connecting to my own PC to this port 9000, which we see is the Spix port. Okay, that seemed to work. Then let's input text to the user field first. What I will do is to use the session object, session, and I will do input text. And next I will be describing the object within the structure on the application. So in my main window, I have a field called user field, and I want to input the text Christoph for the user. As you can see, that worked. Christoph is now in the application, and I can continue also inputting the password field. It was actually called password field. And now you see that there's actually a camouflage password, so Qt still operates and works, inputted into the password field. As last operation, I want to click the login button. So I write session.mouse-click. And this time I'm describing the login button as being in the main window, and there is some element that just has the text login. So I will be using these double quotes here and write login. So this signals Spix to click on anything that is within the main window and somehow has the text login on it. And when I click this, you will see it automatically clicked and changed to the next screen where I can now work on. This I did in an interactive session, but what I actually want to do is to just combine all of these steps in a little Python script to always run on start, so I do not have to input the login data all the time. So, as you have seen, we can now input text or click in our application without actually going there, and we can all record this in automated Python scripts. Here are some examples how to find the objects in your application when you want to interact with them. So input text or click on them, for example. The first example would be to find the objects by ID. As you might know, in QML we can give a little ID to each of the elements. So for example, if I go to the app content, you will see the ring will have a ring ID. So I can find it by Spix by just referring the ID ring. My main window already has the ID main window. I always put main window so I'm sure in which window I want Spix to operate. Next, maybe I want to again put input into my user field, and the user field will be in a parent object called row layout. So here I have the path, main window, row layout, user field to guide Spix to the location, and then Christoph for the text to be input. I also can leave out that middle part if I only have one user field in the whole application. So I only tell Spix, look, inside main window, look through all elements and all their children and find a user field. And when you find it, input the text Christoph. So you can leave out these middle parents and only directly address the child if the name of the child and the ID of the child is unique, which in QML IDs should be unique, it should be. Another possibility would be to find text. I have to be honest with you, the functionality to find text was only added by us later. So I will give you a link in the description where you have an improved Spix where you can find texts, for example, in the application. So when you have these changes, you can use cool features such as this double quote marks to find written text in the application. Find the text cancel in the main application and click on it. Or if there's multiple cancels, maybe there's a cancel in the dialog and cancel somewhere else in the application, Spix might find the wrong one first. You might specify the parent to say, find the cancel button in the dialog and click this one and not the other one. With our changes, you can also find an element by child index. Imagine that you have multiple rectangles in your applications, but you really only want to click the second rectangle. With this special syntax, where you just have like a hashtag like number 2 after it, you will be able to find the rectangle number 2 in the application. Lastly, what we added to Spix was finding elements by properties. So maybe the elements do not really have a name or they don't have a text, but you know that is an element that always has the same color. So what you can also say with our changes, main window, and then find something that has the color being green, for example. So here it's just checking this property. Or alternatively, find something that is 100 pixels wide. This makes your code invariant to changes. Imagine you move around objects. Now Spix is able to find these objects within your applications only being described by their properties, their texts, or the parent-child relationships they are in, and Spix does not use like a position or something like that to find the elements. With this, we are able to still develop the application, move things around, and still use Spix for automated input on the way. What you can see here is now that little script which I have shown to you before in the interactive shell, but now written down in a single file. What I do here is I want to log in to my application, which is actually already running. So I want to input the text, in the user field, Christoph, the secret password named secret, and then also do the login click. And after that, I want to confirm that the ring that we know from before is existing. I can run this little script, and when I run it, it will write that the ring is actually not visible, which is wrong. And the reason for this is that the script was too fast. It was actually looking before the screen was fully filled with all its content. So what we sometimes need to do with Spix is to wait until an object is there. And here we actually have to wait for like 0.1 seconds until the screen is fully loaded. So you need to decide on these times. So when I write sleep for 0.1 seconds here, and then restart my application. So I need to kill this application, restart my application, and run my script again from my terminal. You will see it navigated to that page, and now the result for is the ring visible is true because the application had enough time to put all the contents on the screen, and only then Spix went and found the object which was then there. So this is how you write these little tests that you might use in your CI to check whether an object is there after navigating through the application. Another cool feature of Spix is that you can take a screenshot. And we can use the screenshot for more cool features later. But first, let's take the screenshot. You can see I already started the Python console again with the application running in the background. And now I need to type the take screenshot command, which takes 2 arguments. The first one is what you want to screenshot. You can maybe only screenshot individual elements or the whole screen, which would be main window in our case, and this is what I want. And the second parameter would be where to store it. Let's say we store it in the temp directory and there in screenshot.png. And this will either give you an error when it doesn't work, but this time it didn't give me an error. So here in temp, I will now have a screenshot somewhere being here, and you will see it's actually the full application screenshotted as we just saw it. I did another small little trick. I recorded a reference screenshot the same way before. This way, we might find out image similarity, which is one cool thing that you could do on your CI. So for example, we would go to our LED app folder here, where I prepared a little script that compares image for their similarity and tells me whether they're the same or maybe not the same. So we can look at this script. It's called image similarity. And I'm using skimage as a library here. So with this skimage matrix structural similarity or ssim functionality, I want to find the difference between a reference image and a screenshot. This will print out just a number, but after that I can decide whether these 2 images are very different or maybe the same, and maybe act upon this, maybe write an email when they are not the same anymore. This might be useful on the CI. So when I go out of here and I run the script image similarity, then you will find it will tell us the screenshots are similar but not the same, and the similarity is 89%. If the images would be the same, I will just delete the screenshot here and copy out the reference. So let's suppose we had the same screenshot as the reference. Then the image similarity script would just say the screenshots are identical. This is what we want to reach on the CI. So with this, we can simply send an email if the application does not look the same as before, and this might be something that is useful to you for your testing. In a second example where I work with screenshots, I don't take a screenshot of the whole image, but I take a screenshot of an individual element. You can see here that I want to take a screenshot from main window slider only, and I save it in temp slider. So when I do this, again, nothing means no error. I will see that there's actually a slider image being taken and stored in my temp directory. I wrote a little script here as well, which is called findimage.py. We can look in it first, where I use OpenCV to find a reference, the slider in the reference. So I can, for example, find out if an element still exists on the screen or if its position is still correct. I will then mark the result of the image with a red rectangle around it. So without further ado, let's go out of here and run this find image script. And voila, you will see that on the right side, we will have our slider, which is now marked with a red rectangle, which means my program found this little slider screenshot within the reference screenshot that we have taken before. How cool is this? The last cool script I want to show you is about actually finding the differences between two images. So I have taken two screenshots. The first screenshot is the reference screenshot that shows the application how it should look like with all the rings attached. And the second screenshot is a screenshot where by mistake some of the rings are actually missing. With the automated script that you will also find in the code examples, you're able to actually visually spot the differences. I'm again using OpenCV and Python for it. So when I write Python and then say show differences, a little window will open, and in this window you will see how the differences between the two images are marked with a red border. So you can see in this example, these four rings are actually different between the two images. This you could use, for example, to send as an email from your CI to warn all developers that the application might have changed its appearance between two runs or two commits. The most important part about embedded obviously is that everything can also be operated remotely. So here I'm using Spix running on this embedded board, and I still operate it from my laptop here by using the IP of the board. I can simply input fields like Christoph and also the secret password, and then remotely click on the login button, and as you can see, it will change the application on the embedded board, and I can thus remote control everything in real life on the embedded target. Okay, now let's summarize the pros and cons of using Spix for automated GUI testing. First, you're obviously saving time during development. So you quickly navigate to pages. You can set up certain situations to work on. For example, if a mistake only happens when you do a certain input, you can persist these setups for your colleagues. So you simply check in your Python scripts and they can reproduce the steps that it took to reach a certain bug. You can try the same thing 1,000 times. You know these bugs, they only happen sometimes. And for these bugs, you might want to write a little script that does this input over and over and over again, run it overnight, and it might find the bug that is actually happening in the code. You can sweep value ranges. If you have a slider and maybe the situation that a bug only happens at 42%, then the script might check every value like 1%, 2%, 3% up until 100% for you and find out that 42 is actually the problematic value where your application crashes. You can extend your CI checks to be more visual. You can make your CI send you pictures from differences for reference images, by the way. And there's some cons to Spix as well. Spix only works in simple cases. So the element exists check, the input was accepted check, that's all fine. Screenshot check, we have all seen this. But when it comes beyond this, Spix is not the right tool for you. It's only meant to be used with small scripts that you write and not fully fledged test suites that run over hours or run through like 100 screens of your applications. So you also saw in the application or in the video that I had to wait between steps because Spix doesn't know when a screen is ready. And it also cannot await until an element is there. So this all makes it kind of manual and makes you put in the waits for Spix while Spix should do the waits for you actually. So for serious testing, you should consider using Squish, which costs money, but still is the tool to be used for big testing applications such as fully fledged test suites on your application. The Spix I've shown you needed some changes to work for all the shown use cases, and you can find these versions of Spix in our GitHub in the links under the video. In conclusion, if you think that Spix is the right tool for you, you can contribute on GitHub to help and make it better. But currently, if you want to use it in production, plan for extra time to integrate Spix in your application. Otherwise, there's always Squish. So, for GUI testing, I think that already was a lot for today. Thank you for watching. If you like this video, maybe you want to share it with your colleagues. If you need help testing your Qt or QML application automatically, reach out to us at KDAB. Goodbye and auf Wiedersehen.